Problem number 6.1. Let C1, C2 up to Cn be scalar not all 0 such that sigma I is equal to 1 up to n Ci into Ca equals 0, where Ai are column vectors in R power n. Consider the set of linear equation Ax is equal to b, where A equals Ai up to An and sigma I equals 1 up to n Ai. The set of equation has, we have four options. Option A, a unique solution at x equals jn, where jn denotes a n-dimensional vector for all 1. Option B, no solution. Option C, infinitely many solution. Option D, finitely many solution. We have a problem which is completely conceptual. For solving this problem, we need to have a definition of independent or dependent. Linearly dependent vectors. This is definition: vector x1 x2 up to xm of same order or dimension n are said to be linearly dependent if there exist scalars k1 k2 up to km not all zero such that k1 into x1 plus k2 into x2 plus up to plus km xm is equal to 0. In case of dependent, we get arbitrary element. In this problem, instead of k1 k2 km, they have given c1 c2 up to cm and c1 c2 cm be the scalar. Instead of x1 x2 xm, they have provided a1 a2 up to an are vector in R power n. They have provided vector in R power n, which is n-dimensional vector. Now n-dimensional vector B, these are the elements, which is n cross 1, elements B n cross 1, elements B n cross 1. Now we have n vectors of dimension n, so we have all n-dimensional vectors. Now we can create matrix with the help of these vectors. Let the vectors be a vector, then it will be a1, it will be a2 up to an, will give us n cross n vector. Now finally we have a vector which is n cross n. Now augmented matrix will be AB. Now AB will be A1 A2 up to AN, and there will be a extra column B which will be n cross, this is n cross n into n plus 1 due to an extra column. this is row and this is column. Now A1, A2 up to AN all are column vectors, and also given that in problem we have B equals sigma from I equals 1 AI, means this completely means K1 plus K2 plus K3 up to Km all column vectors summation, all column vector summation gives us one vector B. So with this hint we can see B depends on column of A. Therefore we can write as rank of A should be equal to rank of augmented matrix AB. This will become our equation 1, where rank of A and rank of AB are equal, and there is a solution. Now we have to classify whether it is unique or infinitely many solution. Given that given C1 C2 up to Cn be scalar, given it is being scalar, not all zero, like in definition we had in the linear combination of C1 A1 plus C2 A2 plus up to Cn An, like in definition C1 C2 up to Cn not all zero, it is given, then vectors A1 A2 up to An are linearly dependent, then matrix A is combination of vectors a1, a2, an. Now if the set of vectors are linearly dependent, some are linearly independent, then rank of A is less than n. We can conclude rank of A is less than n. This will become our equation 2. Now from equation 1 and equation 2, conclusion B, we can make conclusion rank of A is equal to rank of augmented matrix AB is less than n, which is number of variables. Therefore infinitely many solution. Correct option C is correct.